In queues, we have seen in the previous session that queue is working with the principle of first in, first out. Then what is the difference between stacks and queues? The only difference is in deleting the items, in removing the items. From the stack, we know we remove the items which is added latest, right, into the queue. First in, first out, which is added the most recent item into the stack, that has to be removed first. And last in, first out, last item is the most recent item in the stack, that has to be removed first. Whereas in the queue, in queues, the item which is added least recently, right, that has to be removed first. That means all the items will be handled in almost a fair manner. Right? So those coming late will be late into the queue and they will be processed late. Those are early into the queue, they will be processed or serviced early. So the difference in the stacks and queues is in removal of items. So then also the insertion is done at the only end. It is limited to the only end, insertion, the rear end. Whereas the deletion is limited to the other end. So where deletion happens, we cannot have insertion or vice versa in the case of a queue. Right? But in the stack, both happen at the same end. So these are some differences anyway. And otherwise, same using array or linked list, both can be represented. Now, let us see the types of queues. What are the different types of queues? Following types of queues are available. Simple queue. Simple queue. Second one, circular queue. Circular queue. Third one, priority queue. Priority queues. And the fourth one is double-ended queues. This is also called D queues. D queues. Now what are these simple queues? Simple queues, as we have seen, the normal queue is a simple queue where the insertion and deletion happens at the different ends. So this is to be taken as the front and this is to be taken as rear end, right? Or wherever there is insertion happening, this is taken as front end. Where there is deletion happens, right? This is the simple queue. So insertion and deletion happens at two different ends. Insertion incrementing the rear, deletion is incrementing the front pointer, that we have seen. That is a simple queue. The circular queue. What is this circular queue? Circular queue is the front and the rear are connected. So here if this is the rear, so this one is again connected. So the front can be connected back to the rear end. So this type of queues, where suppose there are 1, 2, 3, 4, 5, 6 items in the queue, right? 6 items or any number of items. Now after getting the services, one item, it can get partial service. So a few more services or it has to spend some more time. The reason it is standing in the queue, any item, is not completely done. So it may have to enter into the queue again. Correct? The same item may have another type of the service from there and again it has to enter. Suppose only 50% of the service is being done in one round of the queue. So the item has to come into the queue again. So when the front and the rear ends are connected, the front follows the rear and rear follows the front. This is called circular queue. So the items can be in a circular manner when they are moving in the queue. So this is called a circular queue. Right. So after getting partial completion of work, deletion of the item and once again the same item may join into the same queue to complete the next round of services in practical applications. So usually in process scheduling, in the case of execution of processes in a computer, competing processes, suppose a very lengthy process, it is not completely executed, partially it is executed, but it is put out of the processor, because the processor has to accommodate many more processes depending on its importance or time of execution. It may schedule again next. So one process may have to come back out of the queue. Again it may join the same queue for the next round, completion of the remaining part. So these are called circular queues. Priority queues, the third type, priority. So each item in the queue, each component in the queue or node in the queue can be having a preset priority. What is priority? The rank or importance. Which item has to be serviced first? Which item has to get the service first? So a preset priority can be given to each item. Depending on the priority, we can classify the items of different queues. Suppose, so this item, right, something like this. All these items will be priority 1, suppose, and this will be of priority 2. They stand in the queue like this. So all these items like this. So out of the available all nodes or competing items, the items present in the queue, right, we can classify them according to the preset priorities, importance. Right? I will give an example of this. So third, like this. So all these will be belonging to the priority 1. There can be many items having the same priority. So let them be in the queue. So this is another queue. This is another queue having the priority 3 like this. So all these are items. So among the items which are present in the queue, we can classify them according to a certain priority, which is a number given to them. So 1 priority means highest rank, highest priority. They have to be serviced first. And next rank 2, this one. So this will happen according to the principle of queue only. But internally, there is a preset priority. Let me give an example. For example, see, there are candidates who have come to an college or a school to apply, right, to submit the application forms. But candidates may be of different varieties. There can be people coming from nearby places and distant places, and there can be even males and female candidates also. And once again, there can be some people who are handicapped, right? They cannot stand a long time in a queue. Right? So it is better to have different queues there. One queue for the people coming from less distance, nearby places, and another queue for people coming from far distances. They have to be serviced first. So a separate queue for outstation candidates, and yet another queue may be separately like either male and female, right? Boys and girls. Or one more like for handicapped, because we know handicapped people, they cannot stand in any queue, right? Immediately as they arrive into the queue, they have to be given the service. They are not put a long time in the queue, right? Service must be immediately given. So first priority can be given for handicapped people. So when any handicapped people come, they join in a separate queue. So the priority is 1 for them, because whether coming from nearby places or long distance places, if they are handicapped, they have to be separately treated. So this is normally done. So among the items, different priorities can be given to the items. So that becomes anyway a priority queue. Preset priority will be available. Depending on the importance of that item, it can be given service. Correct? Nearby candidates, they can be serviced later also, because that is not a problem. But even then, there may be many who have come from nearby places. So it has to be anyway managed using a queue only. Right? So in this manner, we can service in a fair manner, so that justice can be given for all. Right? So that is a priority. Even in the systems also, computers also, priority queues will be used extensively. The fourth type is double-ended queue. These are also called D queues. What are these D queues? Double-ended queues, we can have insertion and deletion at both ends. Correct? So sometimes it can be configured to have insertion as well as deletion at both the ends. Then it becomes a double-ended queue. So for example, so this is a queue of one item. Like this. Here we can insert also. Here we can delete also. Insertion. Insert a new item at this end. This is delete. Here also we can insert as well as delete. Insert and delete. Insert, delete. Usually in a queue, normal queue, the simple queue, insertion has to be done at the rear end, deletion has to be done at the front end only. But as a requirement, so we can configure or we can allow the operations at both the ends. Then it becomes a double-ended queue, which can also be represented like this. Like, for example, so here also insertion, here also deletion. Insert and delete. So here also there can be deletion, there can be insertion. So insertion and deletion operations can happen at both ends. That means one end can act as both front end and the rear end accordingly as required. So these are some types of queues. So this is a possible question for sometimes 5 marks, like what is a queue and explain the types of queues, right? 1 plus 4, 5 marks, or can be asked for 3 marks also. List and explain types of queues. So this answer you may write along with the block diagrams. Now next let us see the operations on queues. The operation on queues. So as seen in stacks, similar operations can be listed like 1 queue, right? Second one NQ, DQ, next is empty, size. So these are some normal operations, common operations on queues. Like queue, it is to create an empty queue. First create an empty queue. Create an empty queue data structure. So at the compile time, we know using an array we can represent a queue. So declare an array, right? Before adding items into that. So we just create an empty array. Or using linked list, we start with an empty linked list structure. Right? So to create an empty queue. Next, NQ and DQ. As we have discussed, NQ means inserting an item. Inserting an item. So here we require an item as the NQ. Item. An item as the parameter. You have to supply which item has to be inserted. This is for NQ. So sometimes the question may also appear like explain NQ and DQ operations using algorithms. So say insertion and deletion. The next we are going to study those algorithms. NQ. Inserting an item into the queue. Here the queue gets modified. Right? When we add one more item into the queue, the number of items increase, the queue gets modified. And DQ is to delete an item from the queue. So deleting, just it is popping, removing an item where from the front only. This is at the rear end and this is at the front end only, because to maintain the principle of operation of a queue. DQ, deleting, removing an item from the front. This also modifies the status structure of the queue. The number of items gets reduced by 1 when you delete. Is empty is to check, right? Returns true or false, right? A boolean value depending on whether the queue is empty. It returns true. If it is not empty, if at least one item is present in the queue, it returns false. It is just to check. So size operation is to return the number of items. Number of items at any in queue. Right? At any point of time, when you call this function, it will return the number of items present in a queue. Now this empty, as I told, whenever you are about to do any operation like insertion into the queue, that we see, first you have to check whether the queue is full, and when you have to dequeue, delete one item, if it is empty, you cannot delete, correct? So for such operations, isEmpty is usually used before we do any operation on a queue or a stack even, right? We make use of this operation. So same is the operation. So queue creating NQ and DQ, that is insertion and deletion of items, respectively at the rear end and the front end. isEmpty and size, these are some operations on queues. Now let us see the two most expected operations like NQ and DQ using algorithms. Now let us see this algorithm of NQ, insertion of an item into the queue. I have written the algorithm already, I will explain this. See, step 1. If rear is equal to n minus 1, then it is checking for overflow. Print the queue is full, exit. As we have seen in the case of a stack, when the queue is full, right, we cannot try to insert an item, correct? Especially when we take a static array as to represent a queue. How do you say when n is the number of items in the queue, fixed, n is the size of that array name is taken as a queue here, n is the total number of items, then n minus 1 is the last index, correct? So when rear becomes n minus 1, queue is full, we cannot insert any item, correct? So this check we have to do before we insert an item, whether the queue is full. So if it is full, exit, we cannot insert any item, end of that, end if not, means either queue is completely empty or partially filled. In that case, we can definitely insert a new item. So the step 2 is regarding checking the queue is empty. If it is empty, the first one we have seen checking overflow. The condition is called overflow when the queue is full. If not, it can be empty, first case. If it is empty, then that means if front is equal to minus 1 or null, I have written in or null. See, front is equal to minus 1 means there is no even front item, not even rear item. So even rear is also minus 1 there, correct? You can take rear also minus 1 because usually we increment rear when we insert item. So either front also we can check, rear also we can check, because when there is no item and the queue is empty, both will be null or minus 1. That is why I have written in bracket here. If front is minus 1, make front 1. Rear is also, make front 0. Rear is also 0 because when you increment, it becomes index 0. That means first item is there in the queue, correct? So when the queue is empty, when we are inserting one item, that item becomes the first item in the queue, correct? That is why, how do you denote the first item? By having the index 0. In the array, index 0 means first item. That is why, if it is empty, then whatever you insert becomes the first item. So the index of that we are setting front as 0, rear is also 0, correct? Having only one item, front is also 0, rear is also 0, because the front and the rear end are same there, because only one item. So this is what we indicate. If it is not empty, already it may have some items, correct? It is not full definitely, either it is empty or partially filled. If it is partially filled, some items will be there, then rear and front will be definitely different. So in that case, else rear you increment the rear, and then to that position assign the item. So Q of rear is equal to item. Are you getting this? So incrementing the rear, this is a very important step. Else increment the rear and then assign the item to the rear position. That is what is the insertion. So anyway, we know insertion is the rear has to be incremented. Rear is equal to rear plus 1. But we have seen the conditions. If it is full, we cannot insert. If not, either it is completely empty. In that case, we have to increment the front and rear to make it as both 0. Because after inserting one item, the front and the rear will become the same location, 0. If not, partially the queue may be full. Rare is already incremented. So increment further to assign the item to the rare position. So that is how we can insert the item at the rare end of the queue. Hope you have understood this. Correct? So last step is return. So this algorithm may come for 3 marks individually or together with the DQ it may be for 5 marks. So very simple algorithm. Even if you write step 1 and this portion, you can skip this one also. In some study materials, the step 2 is skipped, right? Just directly increment the array. If it is not empty, if it is not full, you can directly increment the array and assign the element to the item to the rare position. That also can. But this is an elaborate algorithm. Hope you understood this. Next, we shall see the DQ, deleting an item from the queue algorithm. Now let us see the algorithm DQ. That is deletion of an item from the queue. Now similar to that step here also, you have to check first whether the queue is empty. Now let us see. Step 1. If front is equal to null or minus 1 in the case of array or linked list, I have given like this. Front is equal to null, then means checking for underflow. Underflow is whether the queue is empty. If queue is empty, front and even rare also become null or minus 1. There is no item in the queue. Print queue is empty, exit. If not, means queue contains at least one or many items. So in that case, you can definitely delete the item, DQ. So first store the item at the front position, which is to be deleted, into the variable item, so that we can display it later, which is the item getting deleted. Only for that sake, we may store it. This is, if required, you can store this. Item is equal to queue of front, because that will be the one which is deleted now. Step 3. If front is equal to rare or is both are equal to 0. What do you mean by this? There is only one item. So if the queue has only one single item, front and the rare both will be the same, index 0. So if front is equal to rare, then it means only one item. Delete that one also. How? Front is equal to null and rare is equal to null, or minus 1 also. Front can be made minus 1, rare also can be made minus 1. That means the only one existing item is also deleted. So this one, step 3, in case the queue has only one item, that is, you check if front is equal to rare. If not, there are many items in the queue. If not, this one, if it is false, that means there are many items, not single item, but not empty also. There are many items. Then you can increment the front as usual. Else, front is equal to front plus 1. Increment the front to delete that item. So, total algorithm of deletion is first check whether the queue is empty. If yes, anyway you cannot delete it. Exit. If not, two cases are taken. The queue can be having only one item. It's a special case. In that, you make both front and the rare null or minus 1, right? Minus 1. In the case of array, both front and rare are made either null or minus 1. If it is having only one item, that is front is equal to that. If not, there are many items in the queue. What you do is increment front. So the item at the front getting deleted. So this is the algorithm for DQ or deletion of an item. So these two algorithms, as I told, are very important algorithms. Now the last section of this one, let us see the applications of queues. As I discussed, there are many applications of queues in practice, in various applications. Like as you have seen the normal queues at any service counter, it is the fair policy, the best way to manage competing resources. When resources are limited and competing processes or entities will be more, so the best way to manage is queues. And some applications will be in simulation. What is simulation and modeling? Right? Simulation and modeling. Usually the complex processes, complex applications will be first simulated using computer programs. When the simulation is working perfectly according to the plan and design, then the actual model is constructed, right? For example, see, satellite launching is having enormous effort as well as the amount of budget, right? So usually before having the actual final product, a prototype is done. Simulation is done using programs, whether all the processes modules are perfectly operating, giving the expected result or not. If satisfied, then only you actually construct the model, which saves a lot of programming time as well as effort in case of it is a loss, and saves a huge amount of money also for complex and really big projects. So simulation is done using automated tools. So for simulation, queues will be used. And next, in operating system principles like scheduling algorithms, right? Various scheduling algorithms in process scheduling for processes to manage process management. So process management is a very important functionality of an operating system for a computer. Different processes will be happening, especially in multi-programming, right? Multi-programming systems, multi-programming or multitasking, right? Systems. Different programs, many programs will be on execution simultaneously. So processor usually is a very important resource, may be limited, maybe one or a few only in a system. So all these processes have to be executed with the help of a processor only. So which process, when has to execute, right? So depending on so many parameters like priority of processes, arrival time, waiting time, execution time, all those things, there are various algorithms to schedule the processes. Scheduling is which processes have to be actually executing at a given time in the main memory using the processor. All the processors cannot go into the main memory because main memory is also a limited resource. Even the processor has to work with only a few at a time. So simultaneous processing is also possible, but still there is a limitation to the number of processes which can be simultaneously executed. So there is a need of proper scheduling, which is carried out using various algorithms, right? Like first in, first, all those things. So that you will study anyway in higher classes when you are extensively studying operating system principles. In those algorithms, queues are being used. The processes are first put into various queues. So accordingly, they will be processed. Multi-programming, as I told, multi-programming operating systems or wherever applications work with the multi-programming systems. Then print queues, simply, right? Print server queues. When usually in a lab or where multiple users work with the different machines, there can be limited number of printers. So when different users give the command to print their documents from individual computers, connected computers, the same printer may maintain a queue of processes, queue of print jobs. So accordingly, one by one, all the print queues, print requests from various machines can be then executed or printed in queues. So to maintain the print queues. And even in buffers, like various commands given, the usually buffer area for any kind of applications, they will be storing all the requests or the documents in a queue. So usually this is also done in the system. So there are various in various application programs, right? Various applications. Queues are being used extensively to properly serve various competing entities. So as I told, wherever there is a competition to get a limited resource available is less, and the competing entities to get the same resource are more. So the best possible way is to put them into a queue. So these queues, these are some applications of queues. Now we have come to the end of the sections of the queues, right? Next, let us see the linked list data structures. Thank you.